but I could have just given you the formulas and say, okay, here's the formulas, apply it, right? So the first one I derived for you guys, the sum of the terms of a geometric sequence. And then if the value of R is less than 1, now here, putting it as the absolute value less than 1, that just means you don't have to put greater than 0, less than 1. That's the reason why. Okay, and so then we get this convenient formula. So this is only applicable if the ratio is between 0 and 1. Otherwise, you'll be adding bigger and bigger numbers. Okay, so we're going to use that idea for number 3. All right, now here's an example. Now there's an important aspect of the number 1 problem, and I'll point that out. So we have our geometric sequence. It starts at 1,000, and then we begin to multiply by 1.1. 1.01, sorry. So here's the explicit formula. I'm just going to write the sum of the numbers in the sequence. So this is what we're doing. And then the last time it would have been, we're doing this for the 19th term. Am I right? Let me make sure I'm not doing anything stupid. Yeah, the sum of the first 19 terms, so then when n is 19, we would get an exponent of 18. Okay. So the first term, the second term, the third term, again, the exponent's 1 less. Now, what is this actually modeling? This is what happens when you save money on a regular basis. It starts accruing and gaining interest on the prior sums. So if we multiply 1.01, that's a 1% growth. So let's say you were lucky and you were able to find an account that gave you 1% interest per month. All right, so you have $1,000 now, just put it in the bank. 1 month in the past, that $1,000 got 1% interest. 2 months in the past would have gained 2 months of 1% interest. And 18 months in the past would have gained that interest. So this is adding the sum of that aggregation, getting percentage increases from sums that you put into the bank. So your $1,000 grows, all right? And so when we do the sum of the 19 terms using the formula, right, and if you want to check yourself, this should be $20,810.95. Okay, so notice we're getting more than 20 times 1,000. So if we didn't put this money in the bank, it would have gotten no interest. We would have had $20,000. I'm sorry, $19,000. So the difference that we're getting from the $19,000, if we just put the $1,000 under our mattress for 19 months, the difference is due to the interest. Okay, this is called compound interest. And interest rates are pretty low right now, which is part of the reason why the stock market's booming, is people got no place to put their money, so it's the stock market. There's other reasons. I'm not going to get into economics